Good evening. Tonight we're going to discuss data visualization. Data visualization is one of the first steps you'll do in analyzing your data. It'll tell us what type of data set we have, if it's linear relationships we're looking at, nonlinear, and it'll give us some ideas of the type of algorithms we can use with that particular data set. So visualization is something that we'll be using quite often to look at our data sets. So let's first look at a history of visualization, and then we'll get into some of the specific capabilities of Microsoft Excel. So visualization is a powerful tool. The design visualization of the Roman Marcus Vitruvius is still available today, as are James of St. George, Amazon and Ingeniator, Leonardo, and the Frenchman Gaspard Monge. And historically, it's been used in science and engineering for millennia. The demands of the Industrial Revolution dramatically increased the complexity of design for the systems we were making. And this increased pressure on visualization led to some tremendous breakthroughs. Gaspard Monge's descriptive geometry is one of them. It was a state secret for France for many decades. Visual analysis became an integral part of ensuring correct and optimal functioning of our more complex systems. And visualization was used to communicate to others and also to create historical records. And finally, it was used to help engineers analyze what was going on. And again, this is all because of the increased pressure on visualization to keep pace with the methods and tools of the Industrial Revolution, now, of course, the information age. So data analytics is a major user of visualization, and analytics presents us with two problems. How do we make sense of the data, and how do we communicate the results of our analysis on the data? And visualization is a solution, and it helps by leveraging our perceptive thinking as well as our analytic thinking. Of course, today, most visualization is done with the computer. Computer graphics now are ubiquitous. Almost every PC has some sort of graphic processing capabilities, and some have quite sophisticated graphic processing capabilities. Visualization is going to engage our spatial reasoning ability as well as our analytic reasoning ability. Visualization is also widely used in the social sciences, and the goal is to create intuitive depiction of complex behaviors from massive amounts of diverse social data. This can be things like traditionally used by medical epidemiologists in the social sciences, John Snow's cholera outbreak study, Charles Booth's cholera outbreak studies. And as the complexity of social science analysis has increased, so has the need for better visualization. This is an illustration of John Snow's deduction that a cholera epidemic was caused by a bad water pump around 1854 in London. The horizontal lines you see in black are indications of death. So he noted where the number of deaths seemed to be greater and how it fanned out from there. And studying the patterns of pedestrian traffic, he realized that it was all emanating from a particular pump. But we use graphics to enhance our understanding of a particular problem. We engage a different part of the brain, and therefore more memory is going to be able to be made available to help us understanding. So again, we engage the perceptual as well as the cognitive systems in the brain. A perceptual system operates in parallel, while our cognitive systems operate serially. Doing this enables recognition of related data without the need to recall the parts and piece them all together. So the spatial and perceptual systems in our brain group related information together, and that helps reduce our search efforts. And it also enhances the recognition of patterns, trends, and relative values. Visualizations are used to explain our data. And again, we start in analytics with a visualization of our data so we can see what type of relationships are there, and that will give us a better sense of what algorithms might be appropriate to apply. It also aids us in finding hidden relationships and helps us to identify trends. We organize our space the same way we categorize data. Nominal data is only used to identify elements, and it performs a labeling function. So with a nominal axis, a region is divided into identifiable regions. Ordinal data has the properties of nominal, but also has a ranking or ordering property. And with an ordinal axis, the ordering of the subregions is important. And a sorted tree structure is an example of this. Quantitative data, in addition to ordinal properties, has a metric or measuring rod so that the interval between elements is important. So with a quantitative axis, the distance between elements is important, not just their relative location. So graphics is going to leverage our perceptual sense making. This can assist comparisons by varying length, shape, or orientation of the representation to show comparisons of size or relative strength or whatever other comparisons we're interested in. Animations can show change over time, and color can be used for grouping and to show distinctions. Attentive processing is where we're able to recognize something at a glance. So it doesn't require our thinking. We recognize immediately what's being presented. So of course, this can be used to advantage in visualizations when a display correctly casts the data so that the goal information is apparent. Now to do this, we need to have rules for setting up discriminators, and we need to avoid combinations of visual properties that lead to complication where people have to sit down and think about what they're seeing. Be attentive is at a glance. That means you're going to be able to understand what's being presented in less than 250 milliseconds, or about a quarter of a second. So color can be used as a discriminator to help us in this pre-attentive processing. A difference in color for the target or goal information allows the observer to quickly and accurately detect if the goal is present or not. You don't have to go through and think about it. You just immediately know on the left we have one of the target points or elements. Likewise, a difference in shape is also easily detectable. The observer can quickly and accurately determine if the goal or target element or information is present or not. And again, very quickly we can see on the right that we in fact do have the target. It's a circle as opposed to squares. We have to be careful though, because we can overdo it. If we have two or more features used to characterize a set, we cannot determine at a glance if the target is present. We must look at the set and go through it sequentially, decide what's going on. So here, it's not immediately apparent if the target is present. So red blocks are the norm, blue circles are the norm. It's the red circle that is the target or goal that's different, but we have to look through both sets sequentially. We have to engage our analytic thinking, decide what the target is. So this isn't be attentive. It's not something at a glance. We're gonna be slower, and somebody who's able to look at something at a glance and determine what the target or goal is. So if we have a grouping of elements, we can use what's known as emergent features. So grouping can result in emergent features, shapes that are more discernible in the group than in isolation. Contours that distinguish them may become more obvious when they're organized in groups, in contrast to other groups. Symmetry and closure can be more apparent in groups, resulting in a superior presentation of a target group that we're interested in. And of course, with the proper use of symmetry and closure, those emergent features, this can result in pre-attentive effects that we can immediately recognize in a target group. So here we see an example. A target group that is contiguous is displaying emergent features. Its contrast with non-target elements. So unique features of shape and closure are pre-attentive. So here we've got the target does not have closure, and it has a different shape. In this case, it's an arrow as opposed to a triangle. So symmetry is different, and also the closure. And so we're immediately able to detect the target, and we can focus our attention and our actions on the target. On the other hand, just orientation in a group is not going to be immediately obvious. You're not going to recognize at a glance where the target is. So here, the distractor and the target both have the same shape and the same closure. They just have a different orientation. So with no uniqueness in shape or closure, the target is not so obvious. We have to engage our analytic thinking. This is slower than our spatial thinking. And we can see that, yes, if we think about it, this group of triangles is pointed in a different direction, so this is our target. It's not something that's immediately obvious, and someone with better emergent features is going to quickly engage the target with its activity, and of course, we're going to be a lot slower. We'll be slower on the draw in this sense. People often equate our eyesight to a metaphor of photography. In fact, our vision doesn't work like a camera, and it turns out that photography is a poor metaphor for sight. So really, what we're doing with our vision is we're constructing a picture of reality, and we add in our own existing thinking and retained knowledge to the visual construct that we're building. And the image we construct depends not only on the light that enters our eyes, but also our retained knowledge, our expectations, the history, if you will. So take a couple of minutes and look at these two pictures and tell me what's different between them. Take 5 minutes and then we'll come back. Okay, so yeah, it's not obvious to us because our mind adds things that we know should be there, and so we don't think about it. But the picture on the left doesn't have the aircraft engine. The picture on the right does not have the aircraft engine, and the picture on the left does have the aircraft engine. So our minds sometimes can fool us by what we see by adding in things that are missing. Let's take another example. Let's find what's different in these. As a first impression, go ahead, take a minute or two and look at these, and then we'll go over them. Okay, right. It's guy here on the right has blue jeans, and over here it looks like he has a beige colored jeans on. And then finally, let's take a look at this one and see what the difference is. This one's not so obvious, but there's glare on the back of the Mercedes-Benz here on its rear window and not on the right. So on the left there's glare, on the right there isn't. So these days, with the ability of Photoshop and other graphics packages to falsify pictures, it's important to go through and see what kind of differences are in fact there, and not rely solely on our vision we get from our eyes, because that can be deceiving. Our eyes add in our expectations and our aspirations, as well as our retained knowledge to the issues. Okay, so with this background in visualization, let's look at the visualization tools that we have in Microsoft Excel, and we'll start that next.